All right, so we're on 3 variables, which means that instead of working with lines, we're working with planes, right? Because if you remember from geometry, 3 points make up a plane. 2 points make up a line, okay? All right, so how does it work? So with planes, you have intersections still. So you're still dealing with either one solution, a consistent system, if all 3 planes intersect. So there would be a solution. It's a line. And then you have your consistent infinite solution is if all 3 planes overlap each other. Okay. And then you have your inconsistent solution is if all 3 planes never intersect or they don't all 3 intersect at the same time. Okay. So you still have the same things that we talked about with linear. It applies to planar, plane systems. Okay, cool. All right. So those are our things. One solution, no solution, infinitely many. Okay. So here's our first one. We have x minus 2y plus 3z equals 7. And we have 2x plus 7 plus y plus z equals 4. And negative 3x plus 2y minus 2z equals negative 10. Okay. I don't think I left myself enough room, so I'm going to make this a little smaller. Okay, so with elimination, the first thing that you want to do is decide which variable are you going to eliminate. There's 2 ways to work elimination. Way number 1 is to decide on a variable from the beginning and then make sure that you have a positive and a negative of that variable from the beginning. Or you can work 2 problems separately throughout. So we'll do the 2 pieces. So you're going to first decide on a variable. When you're deciding on a variable, you want to look for, is there a negative and a positive of it? That typically helps you with having to multiply by a negative. So there's a negative and positive of each variable. Cool, awesome. Next thing you want to look for is there one with already same coefficient? So you're looking for the same coefficient. So opposite, but the same. So in this case, it looks like y would be our prime suspect. Do we see that? Okay, y has 2. 2 that are the same, and it has a negative and a positive to work with. Do we see that? All right, so the variable that we're going to eliminate is y. Second, you're going to choose 2 equations. And eliminate. So the first 2 equations that I'm going to work with are 1 and 3. And the reason why I'm going to work with 1 and 3 is because there's not any manipulation to y that has to take place. Do you see that? My y should automatically eliminate once I combine them. Okay. Give me a second. I'm sorry. After 1 and 3. So choosing 1 and 3, notice how my y's eliminate. I have 1x and negative 3x makes negative 2x. I have 3 and negative 2z, and that makes positive 1z. I have 7 and negative 10, and that makes negative 3. So here's my first 2 variable equation. Are there any questions how and why y was eliminated? Okay. Step 3 is to choose another 2 additional equations to eliminate the same variable. Okay. So this time I'm going to use 1 and 2. The reason why I'm using 1 and 2 is because my y is negative here and my y is positive here. And I won't have to worry about multiplying by a negative. So I have x minus 2y plus 3z equals 7. And I have 2x plus y plus z equals 4. Now this one isn't straightforward because my y's aren't automatically eliminating. So I'm gonna have to do a little manipulation in order for my y's to eliminate. So I need to somehow turn y into a 2. What do I need to do? Multiply everything by 2. So now this becomes 4x plus 2y plus 2z equals 8. And that's what I'm working with now. So I have 1x and 4x, and that makes my y's are going to. I have 3z and 2z, and that makes. And I have 7 and 8, and that makes 15. Okay, this is an occasion where I can see that there's a common factor. So there's a GCF here. When there's a GCF, I use that to make it a smaller equation to work with. My GCF here is 5. So I can divide everything by, so this comes down to being x plus z equals 3. Are we comfortable with that? Not everyone will have a GCF, exactly.
So if there wasn't,
Then you just,
the answer.
exactly. If there wasn't a GCF, then you would just stop. Questions on step 2 and 3. Step 4 is you're going to eliminate your 2 variables. Eliminate using your 2 variables. So I have negative 2x plus z equals negative 3. And I have x plus z equals 3. In order to eliminate here, instead of adding, I'm going to have to do what? Subtract, because that means I'm multiplying everything on the bottom by negative 1. So now when I combine, I have negative 2 and negative 1. What does that make? Negative 3x. I have z and negative z, and that. And negative 3 and negative 3 makes. So what does x equal? X equals 2. So now I know what x is. And step 5 is where you reverse substitute. You're going to substitute in your variables until you have found all variables. So I can substitute 2 into here, right? To solve for z. So 2 plus z equals 3. So what is z? Z has to be 1. And now I have x and z, so I can substitute back into either one of these equations and solve for y. So I'm going to use equation 2, because y wouldn't have to be multiplied. So I have 2 times 2 plus y plus 1 equals 4. That gives me 4 plus y plus 1 equals 4. 4s are going to cancel out. So y plus 1 equals 0. So what does y have to be? Y has to be negative 1. And now you have all 3 of your variables. Are we ringing some bells? Good. Because I promise, I know that your teacher taught you this.
Oh, because it was you.
Yeah, I can verify that. All right, so you write it as a ordered triple, X, Y, Z. So as X, Y, Z, my answer is 2, negative 1, and positive 1. And that's elimination. So again, step 1, decide on which variable you're eliminating. So paying attention to whether you have a negative and a positive and quote unquote same coefficient. Step 2 is choose 2 equations, the first 2 equations that you're going to eliminate that variable from. Okay. Step 3 is choose your second 2 additional equations. that you're gonna eliminate that variable for. Step 4 is an eliminate using 2 variables. And then step 5 is where you substitute all variables back in. And that's the elimination for 3 variables. What are your questions, comments, or concerns? Because we needed to cancel out our z's and they have to have opposite signs. So we multiply it by -1. Yes. You can use elimination, and we're about to review substitution. So what the problem calls for is totally up to you. My job is to teach you both, and then you have to decide. Now on your test, there's part of your test that is paper-based. So on the test, you will have to solve one problem via elimination and one problem via substitution. Okay. So that there is a paper handwritten part to your test this time. No. Yes. I feel like it is. It's a little tedious, but doable. No, we're about to review substitution in a little bit. All right, so inconsistent. So we're gonna talk about what an inconsistent looks like. So we're gonna do elimination again. So step 1 is to decide which variable to eliminate. Looking at what we have here, what would be the easiest variable to eliminate? Good job. It would be z. So I don't know what happened there. We're attacking the z's. Okay. So step 2 is to choose your first 2 equations. So I'm going to do equation number 1 and equation number 2. So I have 2x minus 3y minus z equals 0. I have negative x plus 2y plus z equals 5. Z's cancel. I'm left with x minus y equals 5. Good? I'm waiting. What would be the next 2 equations I use for step 3? Two and 3. You gotta get another 2 variable. So we would use 2. So you need another time where you eliminate z. So like Bella said, we would use 2 and 3. So I have negative 1x and I have positive 3x, and that's going to give me 2x. I have positive 2y and negative 4y. That's going to also give me. What happens to my z's? And I have 5 equals 1. And what happens? I'm going to ask myself, is there a GCF? There's 2. So what do I need to do? Divide all by 2. So x minus y equals 3. What do you notice between steps 2 and steps 3? They equal different things. Can x minus y equal different things? No. So right here, you're done. Because what does this mean? It's inconsistent. So there is no solution. If the 2 variables following the same operation equal different things, then you have nowhere to go. Because this is basically you're saying 5 equals 3. And is that a true story? No, 5 does not equal 3. So when this happens, this means what? It's inconsistent, so therefore there is no solution. It just means that if you pick the wrong one, it may take you a little longer. Yeah. So if you choose like bigger numbers or harder route to go, you'll get there. It's just going to take you a little longer. Okay. All right. We're comfortable identifying no solution? Cool. All right, so we're going to talk about infinite solution. All right, which variable would be the easiest to eliminate? I would say Z again. I mean, unless you want to multiply by 8. It's either multiply by 8 or multiply by 2. Which would you like? If you wanted to get rid of X's, you'd have to multiply by 8. To get rid of our Z's, we're going to have to multiply by 2. So we decided on Z. Okay. So step 2 is choose which 2 equations we're going to work with first. 1 and 2. Good call. So X minus Y plus 2Z equals 1. We have X minus 2Y minus 2Z equals 4. We get 1x and 1x mixed. We have -1 and -2y. Our z's do what they do. And 1 and 4 make 5. Okay, so that's our first 2 variable. Now we're going to find our second 2 variable. So which 2 equations should we use to find our second 2 variables? Good job. 2 and 3. Well, it doesn't matter really. You could have done 1 and 2, 1 and 3. So if I do 2 and 3, what's going to have to change? What kind of 2 though? A -2. So if we choose 2 and 3, you're going to have to multiply by a -2 because you have to change that negative into a positive. So this guy is going to have to be multiplied by -2. So now I have -2x, positive 4y, positive 4z equals -8. You don't have to cross out, but I like to cross out so that I know I'm done with it. So I have -2x and -8x, and that's going to make -10x. I have positive 4y and positive 11y, and that makes, I have negative times a negative is a positive, right? My z's are going to, and I have -8 and -17, and that makes -25. That doesn't look like a 5 to you? What are you talking about? I see 15, Angela. You know, happens to the best of us. Huh? What? What are you talking about? All right, so now I have my 2 linears. So we have 2x minus 3y equals 5. And we have -10x plus 15y equals -25. We have a GCF, don't we? Which we didn't call out here. So I'm going to have to divide each one by 5. Because no one said anything. I was just gonna keep going. And no one said anything, you know. So. Oh, you're waiting on me? Oh, okay. Nope. I did not. I could see 10, 15, and 25, guys. I told you you just didn't see the 5. And I added correctly. All right. Anywho's people who are harassing me. What do you notice happens here when I combine them? So many things cancel out. Okay. So what this tells us that we have an infinite solution problem. Okay, what an infinite solution problem means is that we have to define everything based on one variable. So whether it's defining it based on z or not, but this means that there at some point they either two may intersect, may one intersect, but they do not intersect. So this comes down to being an infinite solution. So solving for the variable, if we did x, we would have two variables of x equals blah, 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 and you substitute it in. I guess I'm doing y. In my notes, I did y, and I don't know why. There's a reason why I did. So here we go. I wasn't trying to be. I really don't know why I did. So solving for y, all I did was add y to that side and then subtracted 1. So I was left with,
Wait, where did you get this? Oh, you took the first one.
yeah, equation number 1. This is what happens when you're making your notes at night, you know? You just go with the wind, what you feel in your spirit. And for some reason in my spirit, it said to do this. So this is what I did. So I found y, and then I substituted that into the other two. That's what it looks like I did. This doesn't seem like the right thing to do though.
That's where we find Z.
And then that's where we find z, and then we're done.
So Z is where it meets.
So it meets at a, so whatever x is, so like if I say x is 2, then at y, z, that's where they're gonna meet. If I say x is 1, that's why it's infinite solutions, because whatever I dictate x to be, it's gonna affect y and z. Versus the original, like the other one, I have a specific point where they intersect, right? Like bam. But yeah, no, sorry, my bad, guys. But yeah, just choose it. Probably work with halves instead of thirds, unless it instructs you to solve for y, or in terms of y, or in terms of x, or in terms of z. I'll make sure I include that in terms of what I want you to have. Therefore, you don't have to think about which one to do. Fair enough? Fair enough. All right, so here it wants us to find a real number a, b, c that the graph of the quadratic function y equals ax squared plus bx plus c forms. So we all know the quadratic form, right? Yes. We know the quadratic form is ax squared plus bx plus c equals a number, right? Yeah. Okay. So we're going to solve what the form of this would be. So what its c would be. So if I have -2, -8, that means that my input is -2 and my output is -8. So could I solve for my c? Yeah. Okay. So we're not really solving. We're just going to set it up. So we're going to plug everything in. So this is going to be my output. I just wrote 0, but that's my output. So we have a times -2 squared. This is our first one equation, plus b times -8 plus c, and it equals, I didn't mean to write -8. It's supposed to be a -2 because x is -2, Shona. Equals -8. So when I clean this up, I have what? What's -2 squared? So we have 4a minus 2b plus c equals -8. So that's our first piece of our system. That's our first equation. Now we're going to repeat again for the next numbers. Our next values are 2 and 12. So for x, I'm plugging in. For y, I'm plugging in. So if a times 2 squared plus b times 2 plus c equals 12. Oh. Plus C equals 12. So we have 4A plus 2B plus C equals 12. And then the last one would be, we have our X, we have our Y, we have A times 6 squared plus B times 6 plus C equals 0. So 36A plus 6B plus C equals 0. So all we did was plug in for X and Y. So instead of using A, B, and X, Y, Z, we're now using A, B, C. So your system that I would like for y'all to solve by tomorrow is 4A minus 2B plus C equals -8. And you have 4A plus 2B plus C equals 12. And you have 36A plus 6B plus C equals 0. Solve for A, B, and C. If you can do this, then you can do it all.
I can do it all.
I believe in you.
Miss Jones, guess what? I just want you to know,